This video actually isn't quite over yet. There's a super secret part to it here. And it gives you a nice little trick. So remember in the first example, we started by setting u equal to something and v equal to something, right? And then remember after that, we had to switch to finding x and y in terms of u and v, right? And that time we had to do it in order to plug x and y into the function 3xy, right? But sometimes we choose u and v based on what's inside the function, right? And then the only reason to solve for x and y in terms of u and v would be to compute the Jacobian. There's actually a trick here. So linear algebra, which if you're going to continue in math, I'm almost certain is going to be the next class you're going to take, it gives us a trick. It tells us that the determinant of the inverse of a matrix is 1 over the determinant of the original matrix. Well, how is that helpful? Well, if our transformation is t of uv equals x of uv, y of uv, right? So this would be what we had if we solved for x and y in terms of u and v. Then the Jacobian, dxy duv, would be the determinant of dt. Okay? But if we start by just saying u equals something and v equals something, like last time I think we had u equals x minus 2y, v equals x plus y. If we just start with something like that, we actually have t inverse, right? And that tells us if we give it an x and y, it tells us what u, xy, and vxy is, right? So this t is the inverse to the u, or t inverse, sorry. This t inverse is inverse to this guy. All right. And then here you might not be too surprised to see that the Jacobian duv dxy is the determinant of dt inverse. What you also might not be surprised about is that this matrix is the inverse of this matrix, right? dt inverse is dt inverse, right? Maybe it's more instructive to put some parentheses around this. So what does that mean for us? Well, that means if we want dxy, right, this is determinant of dt, well then that's, by this rule, that's the same as 1 over the determinant of dt inverse. But dt inverse is duv dxy. Right? So let's just rewrite that for clarity. What I'm saying here is d of xy duv, so this Jacobian, is 1 over duv dxy. Right? So I'm not saying that this is a fraction you can just flip over and put in the denominator. That's not what I'm saying. It looks like that, and that's kind of a useful way to remember it. But what I am saying is that the Jacobian here, the determinant of this guy, is 1 over sort of the inverse Jacobian, right? Which is the determinant of this guy, right? And this can be very helpful. Again, so, like last time, remember, let's just do this as an example real quick even. Last time we decided u was x minus 2y, v was x plus y. And then we had to do all this solving for x, solving for y stuff. But here, duv dxy is the determinant of 1 minus 2, 1, 1, which is 1 minus negative 2, so 3. So then dxy duv is 1/3. That's much quicker. Now, unfortunately, in the last example, we actually did need to solve for x and y to plug it in the function. But see how quick the Jacobian was? If we don't actually need it to plug into the function, we can just get the Jacobian like that and save a whole bunch of time, as we'll see in the next video.